Hi, and welcome to Statistics 1. The purpose of this first lecture is, as the title suggests, to give you an introduction to the course. But it's also mainly designed to introduce you to some terminology that's necessary to understand the first week's lectures. As you see from the website, we did this course last year, and one of the first points of feedback we got on the discussion forums was that although this course is designed to be a friendly introduction for anyone who wants to take statistics, regardless of background, we learned early on that we use some basic terms and phrases that not everyone is familiar with. So that's the main purpose of this first lecture, is to get everybody on the same page and to clarify some of the terminology and phrases that are common in the first lecture and throughout the course. Also, if you have any questions about the course, about the structure of the course, or if you have questions about particular phrases or definitions of terms, you can go to the website. We have a glossary of terms that's on the website, or feel free to ask a question in the discussion forums. So if you don't understand a phrase, or if you don't understand a term that I use especially early on, please post a question in the discussion forums, and either I or my team or some other students will answer it quickly. Okay, so let's launch into this first short introductory lecture. So let's start with a basic definition of what is statistics. You could define it in many ways. For something as broad as this, you could just Google statistics definition or statistics meaning, or just look at the Wikipedia page. I've defined it very broadly here just as the scientific discipline devoted to the study of data. That, of course, begs the question, well, what is data? So let's define data. Data simply is a collection of numbers assigned as values to quantitative variables, or characters assigned as values to qualitative variables. That sounds kind of lingo-y and technical, so what do I mean exactly? Let's look at an example. So consider we have the academic record of a bunch of children in elementary school. And that might look something like this if we organized it into a spreadsheet. Think Microsoft Excel. If we're going to be using R. In R, this would be called a data frame. We'll get to that in the first lab. But basically, it's just a data structure that has columns. So here are the columns. And it has a bunch of rows. It's very common for one row to pertain to one student or one case in your data file. So we have a student, their initials in the first column, then their gender. This first student, TR, is male. Their age and months. So these are, as I mentioned, elementary ed school children. And then their grades in certain classes. So what do I mean by data? Well, each one of these little points, so like TR's really nice 95 in math, is a data point. We assigned a value to a variable math score for a particular student. That's a quantitative piece of data. Is TR's name, TR's gender. Those are characters that we assigned as values. So those are examples of qualitative data. Another way to define data is sort of more technical, is it's the lowest level of abstraction from which information and then knowledge can be derived. So at the lowest level, we have data. From data, we can get to information, and as we gather lots and lots of information, we can start to form a knowledge base and form knowledge structures and wisdom. To be clear, a statistician is a skilled person in applying the tools of statistics. So there are lots of examples of that. This is not intended to be an exhaustive list of statisticians, just a sampling. So there are lots of statisticians who do academic research. That's like what I do. So I'm a professor at Princeton. I do research in cognitive psychology, specifically in memory and attention and intelligence. And so I do academic research. I apply statistical tools to do my academic research. There's lots of examples, not just in psychology, but across the disciplines in colleges and universities all over the world of academic research. There's lots of examples of medical research that occurs in hospital settings. There's lots of examples of survey studies, or the most popular are like polling studies to predict election outcomes, or like the census polls. There's lots of research that takes place in the realm of education, like that academic records example. There's lots of research in education and online education going on right now, trying to understand how online education is working. And then finally, there's a big sector that used to be called market research. Now I think falls under the phrase analytics, also falls under this phrase big data, a big area where statisticians are being hired right now. So again, to be clear in terminology, a statistic is just a quantity calculated from a sample of data. And we're going to do this a lot. We're going to get samples of data, and we can calculate lots of statistics. And I'm sure you've done this before, so if you've been in school before, you could get all of your grades and calculate your average grade in a particular subject, or your average across all of your subjects to get your grade point average. An example in our academic records example is the average math grade or average age of students. We could also calculate how much variability there is. We'll talk about this in the second week, how to calculate variability in a sample. But one of the most popular ways to do that is through standard deviation. So we can calculate standard deviation of the math grade. That would tell us how much variability across the students is there in the math grade. So I just mentioned the idea of a sample there. So it's important at the beginning to make this distinction between sample and population. We'll often be talking about samples and populations. So populations, I'll start at the bottom here, are the entire collection of cases or people or subjects, I might use that phrase, which we want to generalize to. So if I want to do a study about all healthy undergraduate students who are taking college courses or taking courses online, that's my population. I typically can't get my hands on that entire population to do my study, to administer my experiment or administer my measures. So I would try and get a subset of that population, and that's called the sample. So the sample is simply a subset of the population. A statistic, as I defined just a moment ago, is a numerical measure that describes a characteristic of a sample. Statistics, hopefully, are good estimates of parameters. Parameters describe populations. So you have samples, populations, statistics, parameters. A basic distinction at the beginning of any statistics course, if you pick up any intro to stats textbook, most of them start with this distinction between descriptive statistics and inferential statistics. And in fact, we'll do the same. The first couple weeks of this course will mainly deal with descriptive statistics. Just how do we summarize, organize, just simplify data? How do we tell a story about what's in a sample's worth of data? We'll then move on to the more difficult task of inferential statistics, which is where we'll learn procedures where we allow for generalizations about the population parameters from the sample statistics. Again, we typically can't get our hands on the entire population, so we'll look at our sample statistics and we'll try and make inferences about the population based on those statistics. That piece is called inferential statistics. Finally, I just want to give you a brief introduction to different research methods, and this is really the topic of week one. There's 2 lectures in week one. and where we'll talk about correlational and experimental research. It's important to know what type of research you're engaged in or what type of research others are engaged in as you evaluate data and as you evaluate the statistics applied to the data. So the simplest type of research method is just descriptive research, just describing what's in a sample's worth of data. That's just organizing, summarizing, describing the data. So in the example of the academic records of elementary school children, we already did that. We organized it into a spreadsheet, we summarized it. We could just give basic descriptive statistics like the mean of the kids in terms of age, or the mean math score, average math score. That's just descriptive, describing what's in the data. Another type of method is correlational research. So we might want to examine the relationship among variables in our data structure. So we might want to say, well, is math grade correlated with history grade? And is history grade correlated with the science grade? Or is age correlated with math grade? All of those are examples of correlational research. And that's going to be the main topic of Lecture 2. We'll spend an entire lecture talking about correlational research and correlational methods. And finally, there's experimental research. And experimental research is sort of the gold standard if you want to do research that gets at statements about causality, or if you want to get at research methods that explain causal mechanisms. So experimental research is very popular and very powerful, and we're actually going to spend all of Lecture 1 talking about experimental research methods. So an example in the context of our elementary school children is we might randomly assign students to two types of schedules. So some kids might be randomly assigned to learn year-round, so they don't get a summer break, they just get small breaks throughout the year. And other kids might be randomly assigned to a summer break, more traditional academic calendar condition. And if we randomly assign kids to those two conditions, we could then look at their achievement at the end of the school year and see if their achievement was affected by that manipulation. So does year-round schooling work better than the traditional academic calendar? And some people have actually done research on that. My final statement in this first lecture is I want to remind you that it is the International Year of Statistics 2013. There's lots of information on this website, statistics2013.org. So there's lots of exciting things happening right now. As I mentioned, there's lots of jobs opening up all around the world, especially in the US, for people who have some sort of skill in doing statistical analyses. So you're in the right place. Please check out more about the International Year of Statistics. I just wanted to pick out one quote from their website. And it's here on this last slide. Statistics is becoming more critical as academia, businesses, and governments come to rely on data-driven decisions, greatly expanding the demand for statisticians. So sit back, relax, enjoy Statistics 1. Again, if any of these terms are new to you, if there's new phrases, definitions that you need clarification on, please check out the glossary of terms on the website. And also feel free to post a question on the discussion forum, and I or my team or other students will get back to you very quickly. Thanks for tuning in, and I look forward to seeing you in Lecture 1.